Hi everybody. In this video we're going to continue with chapter 11 probability, and we're going to take a look at the last topic or section in this chapter, which is Bayes' theorem. But before we go into Bayes' theorem, I want to read you guys a quote from Scientific American, and it has to do with the applications of Bayes' theorem. And it says, artificial intelligence researchers, including the designers of Google's self-driving cars, employ Bayesian software to help machines recognize patterns and make decisions. Bayesian programs, according to Sharon Birch McGrain, author of A Popular History of Bayes' Theorem, sort spam from email, assess medical and homeland security risks, and decode DNA, among other things. On the website edge.org, physicist John Mather frets or fears that Bayesian machines might be so intelligent that they make humans obsolete. So there you go, that's something to think about. Okay, so now let's take a look at example 11.19, and it says, suppose I have 9 indistinguishable boxes containing blue and red balls as shown below. They are of 3 types. Type A boxes contain 1 red and 1 blue ball. B boxes contain 1 blue and 2 red balls. C boxes contain 1 blue and 3 red balls. I mix up the boxes and choose one at random, and then I pick a ball from that box also at random. I show you the ball. What is the probability that you can guess the box type it was drawn from if the ball is red? So notice that we have box type A, box type B, and box type C. Let R represent a red ball, and A, B, or C representing box types. Find A, the probability of A given R, B, the probability of B given R, and C, the probability of C given R. So in these cases, the first thing that we want to do is have a tree diagram to simplify the situation. So notice that first, he or she scrambles the boxes, and then a ball is picked. How many total boxes are there? There's 9. How many boxes are of type A? 4. So that means 4 out of 9 would be the probability for box A. There's 3 boxes that are type B, so that's 3 out of 9. And then there's 2 boxes type C, so 2 out of 9. Then what's the probability of picking a red ball from box A? Notice that it would be 1/2 for each. Picking a red ball in box B would be 2/3. A blue ball would be 1/3. And then for C, the probability of picking a red ball would be 3 out of 4, and then 1 out of 4 for a blue ball. So notice that in all these questions, it's going to be the probability of A, B, or C given R. So we need the probability of picking a red ball. Now, the probability of picking a red ball is going to be the probability of picking box A, intersection red ball, plus the probability of box B, intersection R, plus the probability that we pick from box C and a red ball. So notice that this is simply going to equal 4/9 times 1/2 plus 3/9 times 2/3 plus 2/9 times 3/4. And if we do all the math here, this is going to give us 11/18. Okay, so now we go to answer the questions. For A, they want us to find the probability of A given R. So notice that it's going to be this divided by the probability of R. So it would be 4/9 times 1/2 divided by 11/18. And this in the end is going to give us 4/11. For B, the probability of B given R is going to then be 3/9 times 2/3 divided by 11/18. And then if we do the math, this is also going to give us 4/11. And finally, for C, we have the probability of C given R, which is then going to be 2/9 times 3/4 divided by 11/18, and this is going to give us 3/11. So notice that we can conclude that A or B should be the more likely source of a red ball. Okay, so next we're going to work on example 11.20, and it says 60% of the students at a university are male and 40% are female. Records show that 30% of the males have IB diplomas, while 75% of the females have IB diplomas. A student is selected at random and found to have a diploma. What is the probability that the student is female? So notice that here they want us to find out what is the probability that a student is female given that she has an IB diploma. Now remember that this is going to equal the probability that the student is a female and has an IB diploma over the probability that it's a student with an IB diploma. So let's take a look at the tree diagram of this situation. So notice that at first we have two choices, female and male, 60% chance that it's a male, 40% chance that it's a female. 75% of the females have IB diploma, 25% don't have it, 30% of the males have IB, and 70% don't. So first, let's find the probability of having an IB diploma. The probability of having an IB diploma is equal to the probability of being female and having the IB diploma plus the probability of being male and having the IB. And then from here, we have that this is equal to 0.40 times 0.75 plus 0.60 times 0.30. And if we do the math here, this is going to give us 0.48. So that means the probability of being a female, given that she has an IB, is equal to this 0.40 times 0.75, which is the probability of being female and having IB, divided by the total probability of having an IB, which is 0.48. And this is going to give us 0.625, which is a 62.5% chance. So next, let's take a look at example 11.24. And it says, a computer manufacturer receives hard disks from 3 different suppliers. Marco supplies 40% of the disks, Berto supplies 25%, while Lucas supplies the rest. So that would be 40 plus 25, 65, that would be 35% from Lucas. Disks from Marco have a defective rate of 4%, those from Berto 3%, while Lucas's disks have a 5% defective rate. Part A, a disk is checked at random. What is the probability that it is defective? So let's take a look at the tree diagram. Here we have 3 different suppliers, Marco, Berto, and Lucas. And here is the percentage of disks they supply, 40%, 25%, and 35% respectively. Then let's take a look at the disks that are defective. 4% for Marco, that means that 96% are good. 3% from Berto are defective, 97% are good. And then finally from Lucas, we have that 5% are defective and 95% are good. So for part A, they want us to find the probability that it is defective. So this is going to be the probability that it is defective is going to equal to the probability that it is Marco's and defective, plus the probability that it comes from Berto and is defective, plus the probability that it comes from Lucas and is defective. So this is going to be 0.4 times 0.04 plus 0.25 times 0.03 plus 0.35 times 0.05. So if we do the math here, this is going to give us 0.041. So 4.1% chance that it is defective. For part B, it says, a disk is checked and found to be defective. What is the probability that it was supplied by Lucas? So this is the probability that the disk came from Lucas, given that it was defective. So that is simply going to be the probability that it is from Lucas and defective over the probability that it was defective. So this is going to be this here, 0.35 times 0.05 divided by 0.041. And this will finally give us 0.427.